Welcome back to Chapter 22. This is Part 2, and we're in the middle of talking about water pollutants, the 8 categories. We've already discussed disease-causing agents, sewage, and now we're on to inorganic plant and algal nutrients. Nitrogen and phosphorus stimulate this growth. We've talked about the process of enrichment and algal blooms, and then the increase or colonization of bacteria, which cause the increased VOD, and also the bad odors come from the metabolism of the bacteria. So I don't think there's a lot that we need to discuss on this slide. This we're talking about fertilizers basically. This is just showing Mississippi watershed, and again we've been over this as well, so I don't think we need to spend a lot of time here. Again, the hypoxic zone that you'll see in late spring and summer, created from the nutrients that come down into this area, increasing the DOD, decreasing the DO. Our next category, organic compounds. Organic compounds, when I say organic, I think things that are natural. So organic compounds can be natural, but when we say organic, what we're really meaning is made of carbon. So sugars, amino acids, oils, those are natural amino acid or natural organic compounds in your body. You're made of organic molecules, if you want to think about it that way. We also have human-made or synthetic organic compounds, pesticides, solvents, industrial chemicals. You can see the list. We've already talked about pesticides and how you saw in the population chapter that we did, how pesticides affected the little 4-year-old girls. Some of the ones affected by the pesticide could not draw pictures of themselves and put the lines together. So, attacks the nervous system. Your big 3 here that I want you to try to remember: benzene, dioxins, and PCBs. Those will be kind of part of your bag that tricks. They're all thought to be carcinogens, which means cancer-causing, and all organic compounds. So that gives you 3 to work with there. And any kind of, these are used, it tells you what they're used for, but they're used in lots of different processes from industries. So they can be emitted into the air, they can be emitted into the water directly, or from the air then dissipating down into the water. Fall organics. This is going to be different. I think this was a map originally, so you don't have anywhere to write the slide on your notes. VOCs are found 80% of the surface water sources. So anytime you're drinking from a surface water source, that source could have VOCs in it, very high likelihood, but the VOC levels have to be what is followed under the Safe Drinking Water Act. So the contamination that gets to your faucet has to be minimal. I'm not going to say there isn't any, but it should be minimal, and within the limits. VOCs can also be found in groundwater. You'll see this because these will attach to water and they don't fall out necessarily. So you'll be more likely to see this than sediments or bacteria because they will fall out. Dioxins, as well as being carcinogens, can also be possible endocrine disruptors. And again, we've talked about endocrine disruptors before. That's going to be anything that blocks or mimics hormones in the body. Inorganic chemicals, and these are ones that do not have carbon. So, two examples of this are going to be lead and mercury. Lead and mercury are found in soil naturally in small, minute amounts, but we've also used them. Mercury's in light bulbs. We use them. Lead used to be in lots of different things, and we've taken it out of the gas, we've taken it out of the paint because we know it's so bad. And again, these are neurological inhibitors and can change brain function. It can be emotionally, mentally, fine motor skills, large motor skills. So, and they both are, favorite word, bioaccumulators. And so that means that they can magnify in the top of the food chain. Our seventh is radioactive substances. We've previously talked about radioactivity from nuclear power plants and how we've got hot water from the nuke plants, but also in the mining process, uranium and carbon-14 are naturally in the soil. So when mining, if there are large deposits of those and they're brought up to the surface, then you have your rain and your runoff, so it can get into the water sources. Also, creating radioactive materials such as creating barium or creating X-rays, then you have waste products that have to be gotten rid of, and that can certainly end up in a water supply if people aren't careful. And then natural sources, again, uranium is naturally in soil, so as soil erodes, uranium can be deposited in the water source. Thermal pollution, this is associated with, hopefully you can remember, dams. Not just dams, but that's where we talked about it, was dams. And it can be power plants. Thermal pollution can come from any kind of industrial use of water where they've created steam to turn turbines, that's electrical, or they've used it to cool any part of the processing. And so this water then is warmer than the water normally is in the source and can definitely cause respiration issues, fish being able to breathe, so to speak, get enough oxygen to exchange with the carbon dioxide. They have to breathe faster, so then they actually utilize more oxygen. It doesn't help because warm water doesn't hold as much oxygen as the cooler water. Remember, that's a relative warm versus cool term, and so there's oxygen deprivation. Two types of water pollution: non-point source and point source. Non-point, it's coming from so many different sources into the same water retention area. You don't know where it came from. So everybody in your neighborhood has a driveway. Everybody has a car. That road in front of your house. So anything leaking radiator fluid, transmission fluid, oil, all this stuff gets carried into the water. We don't know where it came from. Agriculture. We don't know if it's Farmer Jack, Farmer Bob, Farmer John. They all use the same fertilizer. We don't know where it came from. It came from one of the 15,000 farms. Point pollution, though, we can pinpoint where it came from. We can take tests of the water and we can say, okay, we have this toxicant down here, but it's not up here, so it has to be somewhere in between. Aha! Here's a plant that uses dioxins, and it must be coming from this plant. So that's point source, when you can determine where that's coming from. Makes it a lot easier to get rid of it, for sure. Okay, we're going to stop here, so that'll be the end of part 2.